This is the Pipistrel Panthera, the best-looking, sweetest, and sleekest four-place plane in general aviation today, created by Pipistrel Aircraft, a Slovenian company founded in 1987, dedicated to the construction of gliders, light and ultra aircraft from composite materials, which has been characterized over the years for its innovation and creativity. Pipistrel were pioneers in manufacturing the world's first electric two-seater. One of their most ambitious projects has been the Pipistrel Panthera, first presented at the 2011 Aero Friedrichshafen as the company's first four-seater aircraft. Its first flight was in 2013, however, the project has suffered several delays, and so far it has not been commercialized other than in experimental versions. The Slovenian manufacturer has focused on the development of its aircraft on reducing energy consumption to a minimum, seeking to be as environmentally friendly as possible. This, together with its technological advances and innovation in the field of electric aviation, make it a major player in the world of sustainable aviation. The Panthera came to represent a great challenge, mainly due to its propulsion system, since Pipistrel announced that a hybrid and an all-electric version would be launched. Fortunately, despite the delays, the Panthera will finally cease to be an experimental aircraft. In early 2022, Pipistrel was acquired by the U.S. aeronautical manufacturer Textron Aviation, a unit of the Textron conglomerate, which also owns Cessna and Beechcraft and is focused on the development of sustainable aircraft, in which Pipistrel will play a leading role. With this, the Pipistrel Panthera project received a new boost, announcing that the aircraft will finally enter testing phases to obtain its certification from the European Aviation Safety Agency. The new project will also seek to make it a more competitive aircraft. The Pipistrel structure is made of anti-static composite materials, carbon fiber, Kevlar, and fiberglass. These materials are used to shape the fuselage of the aircraft and also provide greater strength in flight. The use of state-of-the-art computational fluid dynamics software has optimized the aircraft's organic curves and improved its aerodynamic performance. Its wings have an aerodynamic surface designed to optimize flight efficiency at cruising speed, capable of providing high lift. Its characteristic T-shaped tail ensures low interference drag and helps improve turning characteristics by preventing the horizontal stabilizer from disturbing the rudder at angles of attack. The Panthera's wingspan measures 35 feet 8 inches, height of 7 feet 2 inches, and a length of 26 feet 6 inches. The landing gear is retractable and is made of titanium, so it has a high degree of resistance and properties that allow it to absorb the energy of landings. Also, the whole system is very light, so its weight does not compromise the performance of the aircraft. The airframe is designed to be as maintenance-free as possible, with permanently lubricated pushrod tubes actuating the ailerons and elevators, while the rudder is cable-operated and requires occasional lubrication. The flaps are about 2/3 of their span and are electrically controlled by a two-position switch, which offers two operational settings, 15 and 45 degrees. The flap section over the wingwalk area on both sides is protected with a solid surface, eliminating any chance of stepping on the flap. The Panthera has two step wings with a pair of spars that fit together in the fuselage with a pin assembly. The specially designed wing airfoils are optimized for cruise efficiency and, therefore, speed, while at the same time ensuring high maximum lift and docile stall characteristics. The aircraft's instantly recognizable T-tail ensures low interference drag and helps improve spin characteristics by preventing the horizontal stabilizer from shadowing the rudder at high angles of attack. Its spacious, ergonomic cabin, with a capacity for 4 occupants, is built on a roll cage structure designed to provide greater protection to the crew in case of an accident. Access to the interior is through 2 large doors with a gull wing mechanism for the front seats and a large hatch with the same mechanism for access to the rear seats. The front seats and steering wheel pedals are adjustable for the comfort of the occupants. When closing the doors, the view from inside is amazing. The pilot has a panoramic view of the exterior, and the same happens with the rest of the occupants, so they can enjoy the scenery without interruptions. The design of the seats provides a sporty but luxurious and ergonomic feeling at the same time. The rear seats are very spacious and comfortable, and have a high, standard-size cargo compartment located in the rear which can be easily accessed from the second row of seats. High-quality ultralight leather was used to make the seats, available in black and brown tones, and all of the aircraft's internal and external lighting is provided by LED lights, which give greater luminosity and a premium feel. The control lever is located in the central axis of the cockpit, providing easy and precise feedback and the characteristic sporty feel of the firm, allowing the aircraft to be maneuvered in a fun and intuitive way. It has air conditioning controlled by an automatic ventilation system, which regulates the temperature to maintain it at ideal levels both in summer and winter. Power comes from the 260 horsepower Lycoming IO540, a horizontally opposed 6-cylinder engine designed for use in high-performance planes. Its exhaust system has been customized to generate as little noise as possible and to obtain maximum power. It mounts a custom-made MT propeller to complement the set. Pipistrel originally proposed the 4-cylinder 210 horsepower Lycoming IO390 because its power-to-weight ratio fit the airplane and it could burn autogas. A change was made because Lycoming does not plan to certify it for automotive fuel. This engine swap was better as the IO390 version was unlikely to produce speeds up to 200 knots and, without turbocharging, it was not going to have much power in high-density altitude conditions, which is a requirement topping Pipistrel's must-have list. The exhaust system has been specially tuned for maximum power and minimum noise. The Panthera has been specially optimized to ensure minimum noise and maximum performance, reducing the aircraft's environmental footprint and increasing cabin comfort. As a light aircraft weighing only 2,900 pounds and with a clean and distinct airfoil, the Pipistrel Panthera has a payload of 1,100 pounds. Thanks to its 260 horsepower Lycoming 540 engine, it is capable of cruising at a speed of almost 200 knots at 75% power. The Panthera is capable of reaching a maximum ceiling of 25,000 feet and traveling up to 1,000 nautical miles. It has a standard fuel capacity of 54 gallons with an option of integrating additional optional tanks that will provide an extra 20 gallons per side. However, this modification would increase the aircraft's payload by 240 pounds, thus making it slower and decreasing useful load too. The Panthera incorporates a standard BRS emergency parachute system that must be replaced every 9 years and deploys at a drop speed of 195 knots. The climb rate is 1,300 feet per minute at its maximum gross weight and a maximum speed of 220 knots. With the flaps full, the stall speed is 55 knots, while with the flaps up, the stall speed is 60 knots. Because it is a light aircraft, it needs only 1,220 feet of runway to take off and 1,135 feet to land. If we look at how the Panthera ranks relative to other high-performance single-engine aircraft, we will see that it edges out the Mooney Ovation and Diamond DA50RG, a newly certified model, for speed. It's even a bit faster than the Cirrus SR22T if the latter is flown at 18,000 feet. Take the Cirrus higher and it will outrun the Panthera. The Mooney Acclaim retains its title as class leader in speed. The avionics panel includes a bevy of avionics that equip the Panthera for serious IFR flight. It offers a Garmin G3X touchscreen primary flight display with a second G3X available option, a touchscreen GTN 750 COM nav IFR GPS, a GTN 650 second nav IFR GPS, and a 2-axis GPS slaved digital autopilot. Mid-continent Instruments standby altitude module provides backup airspeed, altimeter, and altitude indications. While this provides sufficient capability, some buyers may view it as a step down from the G1000 NXI found in the new Cirrus and Diamond models. Because of the smaller panel space, it's unclear if the NXI would fit, and in any case, it would be more expensive. On the plus side, the G3X is easier to use without giving up much capability. With the two GTNs, there's more than enough panel space for maps, engine displays, and the primary flight display. The entire avionics suite, while it may not be the most modern, allows for optimal use of interior space and reduces the workload on pilots and crew members, facilitating their interaction with the flight controls. The Pipistrel Panthera has a fuselage heating system that prevents the fuselage from freezing in adverse weather conditions, plus the construction materials give the cabin the power to withstand possible lightning strikes. At the time of its first flight, Pipistrel estimated the unit cost of the Panthera at around $400,000. However, as of today, the price of the experimental version is around $639,000, and the price of the certified version is $750,000. In addition, it is estimated that the sales cost of the units with hybrid and 100% electric propulsion systems could reach approximately $800,000, but it remains to be seen what the cost of these variants will be. If it stands next to the Cirrus SR-22, the Panthera will come off as an aircraft that offers a more stylized, modern, and of course, more beautiful profile, which preserves the classic look so characteristic of small aircraft from the beginning of the century, something that in 2022 is an aspect to consider. However, the Pipistrel Panthera weighs about the same as the Cirrus SR-20 but offers the same performance as the Cirrus SR-22, which makes it a lighter aircraft with more compact dimensions. Although the Cirrus SR-22 is a larger aircraft and can incorporate a larger fuel tank, its total range compared to the Panthera is only 24 nautical miles greater. It is worth noting that the Panthera is a true four-seater, which means it can carry 4 plus full fuel and go 1,000 miles. In the SR-22, you will need to leave a few things behind. Another aspect where the Pipistrel Panthera stands out is in the cruising speed, since it is capable of reaching 202 knots, while the Cirrus SR-22 remains at 183 knots, which does not mean that it is bad by any means, but it is noticeably slower than its rival. On the safety side, both incorporate an emergency ballistic parachute system, which deploys faster on the Cirrus SR-22 at 140 knots, while on the Panthera it deploys at 195 knots. The Panthera's speed performance at low altitudes is even superior to the top-of-the-line Cirrus SR-22 variant, the Cirrus SR-22T. Definitely, both are very good aircraft, so it is up to you and your goals which one to choose. Although the Cirrus and Cessna aircraft are good flying airframes, the European designs, particularly the Diamond and the current Panthera, are plain more attractive. The Panthera's center sticks give it a stronger sense of control, and its gull-wing doors and seating arrangement are other advantages. This is especially true on a hot day with plenty of sunshine when air conditioning is needed. The doors can be fully opened during a taxi, supported by their gas springs, or held half open to provide fresh air into the interior. In the pattern, the aircraft are nice. There isn't a lot of tedious trimming required. Second, even when landing quickly, the aircraft plants without bouncing thanks to the trailing link landing gear. The Panthera has a usable load capacity of around 1,100 pounds. It will take intentional effort to load the CG envelope outside of its boundaries because it has a generous 9-inch envelope. By doing away with the need for complicated and heavy hydraulic systems, its titanium trailing link undercarriage, flaps, and trim are all electrically driven, resulting in minimum weight and high durability. The Panthera excels in its ability to simply fly. Some consumers may be drawn to it just because of its center stick and evenly balanced control forces. Some of the negative aspects of this aircraft can be found in its doors, since, although the gull-wing system offers a sense of luxury, in case of an accident or in a situation where the aircraft overturns, the emergency exit of the aircraft will be compromised. Another criticized aspect of the aircraft's design is the closing and securing system of the doors, which has generated some doubt among people in the industry who fear that in certain circumstances the doors could come off and hit the tail. However, Pipistrel assures that its robust closing system would avoid any similar situation. Some pilots have complained that because the glare shield and cockpit glass are so high, visibility on landings can be somewhat uncomfortable while pilots get used to it. The Pipistrel Panthera is presented as a versatile, light, compact, and fast aircraft, with good and bad aspects. But the most important thing to consider is that the Panthera cannot yet be presented as a 100% finished product, since the 10 or so units flying in the United States are only flying in their experimental variant. It remains to be seen what the final result of the aircraft will be after its acquisition by Textron and the intention to finally certify it as a complete aircraft, which undoubtedly opens an important window for the improvement of its overall performance. This aircraft is unique and has a very efficient performance with an attractive design that will open up a world of opportunities for you to explore. It was specially designed to keep you safe, so you won't have to worry about that. Plus, it is environmentally friendly, so what more could you ask for?